Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. For our second topic, we are going to learn on the CNC machine and controller. So in this topic, you are going to differentiate between two control system, open loop and closed loop system, and for you to be able to understand and write coordinates in absolute and incremental position. So for CNC, as the name it is, computer numerical control, uh, will have its own control system. So basically, the control system for a CNC is a system which control the tool movement. Okay, MCU, okay, the machine control units, contains a machine motion controller for controlling the tool movement. So the tool movement itself can be categorized into two different categories. The first one is point to point, and the second one is continuous path. Okay, let's take a look at the first kind of movement, the point to point tool movement. So for controlling the tool movement using this category, the tools or the workpiece are going to move from one point to another one and perform the required tasks. For example, this kind of tool movement are being used in drilling, boring, reaming, tapping, and punching, where all these operation required a task that is going to be completed at one point. Okay, at each point a different operation will be done. So let's take a look at this example here. We have a tool starting point. So basically the MCU are going to control the tool to move along the path without doing any operation, just moving the tools. And when it reach to point number one, okay, it will do the drilling or boring, and then after finishing the first task at the first point, it will move to the next point, point number two, and do whatever the task required to do, drilling or whatsoever, and then once completed, move to point 3 and next one. So second tool movement is continuous path. So different from point to point tool movement, continuous path means that uh, simultaneously while the tool is moving, it will also do the operation, do the task. So this kind of tool movement is being used for operation like milling, okay, contouring. So we have all the axis of the motion will move or might move simultaneously, each at different velocity. So we have the tools moving from the tool starting point along this contour, along this profile, while simultaneously spinning and cutting, okay, the parts along the line, okay, along the line. So we can see the difference point to point and the continuous path. Then we have the control system. Okay, the first one, or the one that is usually being used in a conventional way, we have open loop control system. So in open loop control system, the step motors are being used. The step motors are driven by electric pulses, and every pulses will rotate the motor spindle through a certain amount. By counting the pulse, the amount of motion can be controlled. So no feedback signal for error correction for this kind of open loop control system. And this will effect in lower accuracy in the positioning of the tools and the parts. So if you look at the diagram, basically we have the input from the electric pulses. We'll send the signal to the controller, and it will control process, and we are going to get the output. For example, it's an input like move at X direction 10 centimeter, 10 millimeter. So it will move, it will send the signal to the step motor, and then it will rotate, and either the tools move 10 millimeter or not cannot be what we call identified, or cannot be validated, okay, because it is just an open loop. Okay, if there is any kind of error, let's say just move like 9 millimeter, okay, there is no way for the user to know either the error happened unless we measure it by hand, by manual. So that is open loop control system. And then let's take a look at CNC, which apply the open loop control system. We have the MCU sending signal to the stepping motor. The stepping motor are going to rotate according to the signal. Okay, so let's say that 10 millimeter, it will need to rotate like 100 times. So it will rotate, and then the rotation is being done by the conventional lead screw mechanism. Okay, so we have screw and the nut. So basically for this kind of mechanism, we are going to have backlash and friction. These two are going to cause what we call as error in the positioning, and will lower the accuracy of the positioning system itself. So this is very simple, and uh, we cannot identify either error will happen or not. Okay, so then we have a closed loop control system. In a closed loop control system, servo motors are being used. Okay, and tachometer is used to measure and feedback its angular velocity or RPM. So basically, we have a sensor that can measure and then give back feedback to the MCU in a unit of angular velocity or RPM, revolution per minute. So MCU are then going to compare the motion command from the MCU and the voltage feedback from the tachometer, and output back to the motor the difference between the two values of error. Resolver or encoder monitors the distance between the distance by which the table and spindle has moved, and send this info back to MCU. So the feedback system, okay, this is the main part of the closed loop control system, is also referred as measuring system. It will measure the output. Either error happen or not, it will send back the signal back to the MCU. And MCU are going to use that signal, use that feedback to correct the inputs that it sent to the controller. So by using this feedback system, we are going to attain better accuracy, but the machine, the control system itself are going to be more expensive, and this is going to be only suitable for large size machine tools. So unlike the open loop control system, which only have input and output, so closed loop control system will have input, output, and the output are going to be measured. The feedback are going to be sent back to the input MCU. So let's say we have an example of the closed loop control system. We have, let's say, we have the MCU send signal to move 10 millimeter in X direction. Okay, and then it sends signal to the servo motor, and the servo motor rotate. Okay, and for closed loop control system, usually we are going to use a ball lead screw mechanism, meaning that the screw will have a bearings inside it, and these bearings are going to circulate between the thread in the nut and the bolt. Okay, and these are going to reduce the friction and backlash, which usually occur in the conventional Archimedes lead screw mechanism. Okay, so by using ball bearings, it will reduce the friction and backlash, and this is going to affect in better accuracy. Okay, either way, so once it move, okay, rotate the lead screw, the ball lead screw. This tachometer or the resolver or encoder are going to measure how much have it moved, what is the speed, and what is the RPM, and based on the value, it will use it as a feedback and send back to the MCU. Let's say MCU send 10 millimeter in X direction, but the resolver only measure like 9 millimeter. So it will send the 9 millimeter input back to the MCU, and MCU are going to correct the value automatically. So this is the closed loop control system. Next, we proceed with the Cartesian coordinate system. So Cartesian coordinate system is a very common one. We have X, Y, and Z. So we have the first quadrant, X and Y positive. Second quadrant, negative X, Y. Third quadrant, both X and Y are negative. And the fourth quadrant. So we have x positive, minus and negative, y positive, y negative, and we also have z positive and z negative. So this is a Cartesian coordinate system. We usually use it a lot in geography and so on. So for coordinate system for CNC machine are going to be established according to the standard industry standard EIA-RS 27A, which include, okay, the first one is the right hand rule. So you have the right hand, so you can use your right hand to identify or um, to determine which direction is the x, y, and z positive. Okay, so let's take a look at this figure here. So we can use our right hand, okay, by pointing it uh, to the front, forward. So our thumbs are going to point to the x positive direction. Our point finger are going to point at y positive direction, and our middle finger, okay, are going to point to the z positive direction of the machine axis. Okay, so the spindle movement is primarily along the z axis. So we have the spindle move along the z-axis. Okay, maybe we are going to imagine that the what we call um, the movement of the part uh, in the exact machine, the parts itself are going to move at x and y axis. But if we look at the diagram, like let's say the first diagram that we have here, we are going to imagine that like the spindle itself is moving at x y direction, okay, but in fact the one that is moving is the platform, the bed with the work part. Okay, the spindle will only move at z direction, downward and upward. Okay, so the coordinate system, we have three axis vertical CNC machine. Okay, only move at x y and z axis. Okay, so we can use our right hand rules to determine which direction is the positive. And then we have machine axis for three axis horizontal CNC machine. So for this machine, the spindle is uh, set at horizontal orientation. So we have x and y is a bit different from the vertical one. Okay, kita nampak we can see that the z positive and z negative is uh, at this direction at our line of sight. So unlike the vertical one, z is uh, from the top to the bottom. Okay, so these are the difference for three axis, and then we have six axis vertical. So additionally to the three axis that we have, six axis vertical will have rotatable axis at x, y, and z. So the x axis will have additional a axis, okay, rotational a axis, b axis at y, and c axis at z. Okay, so we have six axis vertical. Okay, so next let's proceed to the positioning system. Okay, positioning system. We have two different positioning system, incremental and absolute. So let's start with incremental. So incremental positioning system is where we define the location by using or by relatively refer to the previous position. So this kind of positioning system will have some problem if the first position is incorrect or in error. So all the subsequent movement that we have after that are going to be also in errors, incorrect. So for example, this kind of incremental positioning system is being used for drilling. So let's take a look at this drawing here. We have the part origin at 0, 0 here. We have 3 points A, B, and C. So the tools are going to move from the origin to point A, point B, and then point C. So given all the dimension, delta y 0.5, delta x 0.5, 0.5, and 0.75. So if we want to use incremental positioning system, we are going to, or any other positioning system, we need to make a table, okay, that's going to put all the position, all the point in order. So the movement is from point A, B, and C. So we are going to put A, B, C. So starting from the origin 0, 0, movement to point A would be positive 0.5. So we write it positive 0.5 and positive 0.5 at y-axis. So both are positive 0.5. And then from point A move to point B. So it is at the same y-axis, so it will remain 0, but at x-axis it increase 0.5 towards the positive direction. So we add 0.5 and 0, and so on. C will be 0.75 and 0.25. Okay, so if the direction of movement is in opposite direction from point C, point B to point A, so we are going to look at a different kind of value here. It will not be the same. Okay, and basically it will be negative because it is moving to the x negative direction and downward to the y negative direction. And then we have absolute positioning system, the easiest one, where the location is relative to the origin, the 0, 0. Okay, 0, 0 coordinate. So the 0 point can be defined at any suitable point within the limits of the machine tool, and we can redefine the 0 point, the origin, from time to time uh, according to our work part. Okay, so any particular definition of the 0 point remains valid till another definition is being made. So let's say we have a same diagram. So point A, B, and C, but this time we are going to use absolute positioning system. So the coordinate for point A will be relative to the origin 0, 0. So it will be 0.5 and 0.5. And then point B relative to the origin. Okay, remember it is not relative to point A. It is going to relative to point or the origin 0, 0. So it will be the coordinates or the position will be 1 and 0.5. 1 and 0.5, and similarly for C will be 1.75 and y-axis is 0.75. So in this case, if the tool moving at opposite direction from point C, B, and A, the coordinates are going to remain the same. It will not change. Okay, we just need to change the order of the point C, B, A, but the location, the coordinates are going to stay the same. Okay, so that's it for our second lecture. So we have some exercise here. So we have given this in this diagram, we have the origin here. Okay, so by default origin would be 0, 0. Move to point A and then point B, C, D, E, F, and back to point A. So we have you are going to need to write a coordinate for 1, 2, 3, 4, 5, 6, 7 points. Okay, back to point A. So please make a table for both incremental and absolute positioning system, and then you can submit through Kalam in the exercise lecture 2. Okay, that's it for our topic today. Assalamualaikum warahmatullahi wabarakatuh.